You know how teachers sometimes tell us something, but they don't tell us why. They just want us to take it for granted. Well, one of the things that they tell us the answer, but they don't tell us why that's the answer, is when you have anything to the power of 0 equals 1. So I'm going to show you why now any number to the power of 0 equals 1. So basically, any number to the power of 0 equals 1. So x here just could represent any real number. Now, I used 2 as an example. You could use any number you like, and the same thing applies, but we're just using 2 so that it's easier to follow why 2 to the power of 0 or any number to the power of 0 equals 1. So now, let's look at 2 to the power of 0, and we said it should equal 1. Now, let's just start maybe with 2 to the power of 5. So when you hear 2 to the power of 5, you know that is 2 times 2 times 2 times 2 times 2. So basically, you have 5 2's that are multiplied. And so you either multiply it in your calculator, or if you're good with exponents, you know 2 to the power of 5 is 32. Now, how about 2 to the power of 4? Of course, that's going to be 2 times 2 times 2 times 2. So we have 4 2's in there. And you know that would equal 16. Now, can we say that getting from here to here, we took away a 2, didn't we? So we took out this 2 right here. And now we have 4 2's when it's 2 to the power of 4. Taking away that 2 is basically, we could say that's the same as we divided 2 to the power of 5 by 2, and when you divide by 2, one of the 2's disappear, and you get 4 2's. So with that argument, now we could tell, like, getting from 2 to the 5 to 2 to the power of 4, we could just take the 32 and divide it by 2, and we get 16. How about 2 to the power of 3? Can we, with the same argument, say that since 32 divided by 2 gave me 16, to get from 2 to the power of 5 to 2 to the power of 4? Now, can we say 2 to the power of 3 is 16 divided by 2 based on what we said here? And that will give us 8. Because 2 to the power of 3 is the same as 2 times 2 times 2. It's basically 3 2's multiplied by each other. And therefore, 2 to the power of 2, with the same principle, it should be the 8 divided by 2, which is 4. How about 2 to the power of 1? That would equal, take the 4 and divide it by 2, and you will get 2. And therefore, 2 to the power of 0 would be 2 to the 1, which is 2, and you divide that by 2, and that will give you 1. So that's one of the proofs on how 2 to the power of 0 equals 1. We could look at it in a different way as well. So x to the power of 0 equals 1, where x could be any number. Now, can you agree with me that's x divided by x gives you 1? Now, if you look at both x's here, both of them have 1 as an exponent. Now, the loss of exponent says when you're dividing, you minus the exponent. So that's 1 minus 1, which gives me x to the power of 0, which equals 1. So that's another proof how x to the 0 equals 1. That's the proof. X to the 1 divided by x to the 1 gives me 1. And x to the 1 divided by x to the 1 is the same as x to the power of 1 minus 1. And 1 minus 1 gives me x to the 0. So therefore, it's that. The next approach to this is using limits. So basically what we want to do, we want to approach 0, the exponent, we want to approach it from both sides. So we'll go back to 2 to the power of 0, or any, let's use 5 to the power of 0. And we want to see if that equals 1. So what I'm going to do, I'm going to approach 0 from both sides. So what I'm going to do, I'm going to start maybe with 5 to the power of 1. That gives me 5. And then I'm going to do maybe 5 to the 0.1, 5 to the 0.01, and 5 to the and 5 to the power of 0.001, and we could go on forever. Okay, but what you see here, we're approaching 0. We're getting closer to 0 as we go. 0.1 is closer to 0 than 1. So the exponent is approaching 0, and we want to see what happens. Also, we want to approach 0 from the negative side. So here we start with 5 to the power of -1, and we want to start getting closer to 0. So 5 to the power of -0.1, and then we're going to go to 5 to the power of -0.01, and maybe we'll go as far as 5 to the power of -0.001, and the list could go on forever. Now go ahead and take your calculator and do all of these right here. Okay, so that's going to give me 1.1746. We're just going to stick to 4 decimals, and this will give me 1.0162. This is going to give me 1.0016. And now we're going to approach 0 from the left side. So basically we're going to come from the negative side and approach 0. So we will start off with 5 to the power of -1, and that gave us 0.20000. We're going to stick to 4 decimals. How about 5 to the power of -0.1? That gave me 0.8513. How about when we do 5 to the power of -0.01? That gave me 0.9840. How about 5 to the -0.001? That gave me 0.9984. So what we notice, as the exponent gets closer to 0, on this side we're getting closer to 1, and also on this side when you approach 0 from the negative side. So just think of the negative, this is the exponent, and on the number line, that's -1, that's 1, that's where we started, and then you're getting closer to 0 from both sides. And as we're getting closer to 0, wow, we're getting very close to 1 from both sides. You could even go and check out 5 to the power of 0.00001, or throw in as many zeros as you want. And even if you do that, and you put like 4 zeros or 5 zeros or 6 zeros, here your answer is going to get even closer to 1. So 1.0000. If we do in 4 decimals, that's what we get. And if we do the same thing with the negative, we're getting very close to 0 from this side. So it's -0.000001. And we try that, we get 0.9999. And the next number is 8. So if we're going to round up basically to 4 decimals, then it's going to be 1. But let's just throw in 1 more decimal here because it's 8, and then after 3. So we have this number. Now, you notice here we're getting very close to 1. If you want to look at the fifth decimal after this is going to be 1. So that's 5 decimals. And here is 5 decimals. So 1.00001.9998, definitely we're getting closer to 1 from both sides. So as we get closer to 0 on the exponent, we're going towards 1 from both sides. And that's why 5 to the power of 0 simply equals 1. And these are 3 approaches that I've shown you how to prove that any number to the power of 0 would equal 1, with the exception of 0 to the power of 0. If the base is 0, then it would not equal 1. And lots of mathematicians argue if it's 1 or it's undefined. And you could check that out on your own and see if you could arrive to the conclusion on your own. Okay. And now you know why anything to the power of 0 equals 1. As always, keep supporting. If you like this video, don't forget to hit that like button. Comment if you like. Most importantly, subscribe, because your support goes a long way. My channel has over 500 videos explaining math from grade 6 all the way to first year university. Check it out. I recommend it to friends who are studying math at the moment. Again, thank you for watching. Till next time, bye-bye.